Hello, welcome to ATI 4205. This session will address production logistics, including process strategies, process design and development, and process analysis through different tools and techniques. The main idea is to learn how to create a process to produce offerings that meet customer requirements within cost and other organizational constraints. We addressed the process of sourcing and procurement in a previous lecture and how it can be done through a direct relation with the supplier or through competitive bidding process or other channels. The process included purchase order, confirmations, and goods received or receipt. The received items might be put in a warehouse until used. Even in a manufacturing environment, you still have that warehouse or that inventory that you need to save items until being used. This warehouse can be within the production plant, the same area, or in nearby area closer to the manufacturing facility. As stated in previous lectures, the company must decide the size of inventory needed to continue production, point of order, safety stock, other related plant inventory decisions. The proximity to supplier could assist in purchasing the storage to be at the supplier site instead of creating your own warehouse or your inventory. If you are closer, then you can buy just an area within the supplier, manufacturer or manufacturing facility, and then use that area for you as storage. The storage area comes with other related considerations such as space, equipment, people, as we said before, and you don't want to add that to your overhead cost for the manufacturing of that product. Manufacturing processes strategies will define how to produce a product or provide a service that meets or exceeds customer requirements, meets cost and managerial goals. Manufacturing strategies has a long-term effect on efficiency and productivity or production flexibility and cost and quality. Process strategies will assist in process design and in creating a process that produce offerings to meet customer requirements within cost and other managerial constraints. There are four process strategies that can be used based on the product and based on the organizational limitations. These four strategies are process focused strategy, which stresses on low volume, high variety, such as carpentry, where the strategy allows customization. And then there is a repetitive focus where the strategy stresses on repeating processes using modules such as automobiles and household appliances. It has more structure and less flexibility than the process-focused production. The third one is product-focused strategy, which stresses on high volume, low variety, where facilities are organized around the products such as glass, paper, and light bulbs. These processes are also called continuous processes because they have very long continued production runs. And then we have the mass customization focus strategy, which stresses on high volume, high variety of goods and services. It's considered a rapid, low-cost production of goods and services that fulfill unique customer desire, such as Dell Corporation and the high volume with high variety of personal computers options. In the process-focused strategy, facilities are organized around specific activities or processes. You need general purpose equipment and skilled personnel to accomplish the different activities or execute processes. It involves a lot of customization, which gives the product high degree of flexibility, typically high costs and low equipment utilization. Products flow or product flows may vary considerably, making planning and scheduling a challenge. This figure shows an example of a process-focused strategy at a manufacturing company. In the process-focused strategy, we have many inputs and many different outputs. Each product or item will be routed differently and might go through many departments. For the repetitive focus strategy, facilities often organized as assembly lines, characterized by modulars or modules with parts and assemblies made previously. The modules may be combined for many output options, less flexibility than process-focused facilities, but more efficient. This figure shows repetitive focus which is repeating processes using modules where you have different modules inputs that is being assembled into few modules, and those modules being combined for many output options. The repetitive focus strategy at automobile assembly line, different modules such as engines, transmissions, wheels, fuel tanks, and many other modules will be combined to create many outputs. You will see different cars, different modules, different types of the same car. This figure shows the process flow diagram of the repetitive strategy at Harley-Davidson. In a product-focused strategy, facilities are organized by product. This strategy will be dealing with high volume but low variety of products. Most likely, the company will have long, continuous production runs to enable efficient processes. This strategy is typically associated with high fixed cost but low variable cost. Generally, less skilled labor will be needed for a product-focused approach. This figure represents a milk plant that focuses on or around the product of the milk, which have few inputs and variety of outputs, such as the size, the percentage of the fat, the different flavors, and so on. You can make variety of options. This is another example of product focus. This figure shows a steel plant and the different processes involved to convert steel into finished products. And again, it's one input, but it will have variety of outputs. For mass customization, the strategy stresses on fast production with low cost for both goods and services, which satisfies unique customer desire. One of the main features of mass customization strategy that it combines the flexibility of a process focus with the efficiency of a product focus. A very good example of the use of mass customization strategy is the Dell Computer Company. Their strategy was to create a process that will focus on customers directly through building what customers need when they need it with fast response and low cost. The process has been integrated through the company's website, from the browsing to selecting to customizing to ordering to paying, all online and within few minutes. Not only that, but Dell also focused on software design to be simpler and faster for configuration purposes. We can look at the mass customization as a collection of characterization or characteristics that is being learned from different strategies, such as modular techniques from repetitive focus, effective scheduling techniques from process focused, and rapid throughput techniques from product focused strategies. This will make the process design flexible and imaginative, but with tight schedules and limited inventory. This strategy will require responsive partners in the supply chain to be able to meet the tight schedules. Once a process is created, it will be difficult to change and in some cases very expensive. At that point, it will be better to start over and create a new process. It's very important to get it right the first time to avoid any changes. To analyze the current processes and design better processes, we need to answer the following questions. Is the process designed to achieve competitive advantage? Does the process eliminate steps that do not add value? Does the process maximize customer value? Will the process win orders? We can analyze requirements and design a process using different tools and techniques such as flow diagrams, time function mapping, value stream mapping, process charts, and for service industry we can use blueprint diagrams. The flow diagram shows the movement of material. The time function mapping shows flows and time frame. The value stream mapping shows flows and time and value added beyond the immediate organization. The process charts uses symbols to show key activities, and the service blueprinting focuses on customer provider interaction. This figure shows a time function mapping diagram that maps the process of ordering a product as a function of time. The customer will place the order and the salesperson will process that order, and that will take around 12 days. It will wait 13 days in the production control to schedule the activities needed for production and find the resources. Then it will be sent to plant A for printing, which will take 1 day. After it's done, it will be sent to the warehouse where it sits there for 4 days until it's being transported to plant B. It stays in plant B warehouse for 10 days, then it will be extruded that's 1 day process, and then back to the warehouse to be sent to the customer, which will take another day. That's a total of 52 days time frame from the time of order until the time of receiving the final product. Looking at the previous time function mapping, we found that lots of time is wasted just waiting in the warehouse. If we can move the extrusion to be in the same plant and schedule everything to be done within the same time, then we can save a lot of time. We don't have to wait and move it from one plant to another. So that will crash. If you look at this figure here, you can see that will crash the process from 52 days to 6 days only. So the time function mapping will assist in the analysis of the process, identifying the problems that will delay the production, and provide a recommendation to improve the process. And that's why we need these kind of charts to analyze the processes and see if it's working as intended or if it's working efficiently. Another tool that we mentioned was the process chart. This figure shows a process chart for hamburger assembly. Using chart assembly, we can identify the stage where the assembly is, including time passed in minutes and distance travel. So we will know exactly where the sandwich is in the process. Using this chart, we can eliminate non-value added activities and improve the process, improve the response time. So instead of having 3 minutes 15 seconds, we can make it less than that to respond faster to the customer. So for now, that will be all for this session. If you have any questions, please let me know. We will continue talking about the production and processes and the different strategies and how to use them, and then the technologies that will be required to assist in these processes. Thank you and have a great day.